Okay, hello guys, welcome to my channel In-Trance. In this session we are going to discuss on a new topic called pair of straight lines. So in the upcoming videos we will be discussing on this pair of straight lines. If you like my videos, please consider subscribing my channel and like, share and comment on my videos. So let's begin. Pair of straight lines. So as we have discussed earlier regarding the straight lines, now this is somewhat related topic to pair of to the straight lines and a more extended version of straight lines. So here you can see second degree equation in x and y, which is basically ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0. So this is general equation of second degree in x and y. So here you can see delta. I have defined a term called ABC plus 2FGH minus AF square minus BG square minus CH square. So this is a very important number that will decide either it is a straight line or some conic sections. Okay, so this can be also represented in matrix form. You can write A, B, C along the diagonal of the matrix, and you can write H and H over here, and again you can write G and G in the corner, F and F over here. Okay, so the same formula you can get if you will expand this determinant. Now let's see in what cases this general equation represents a straight line and it represents some other conic sections. So if this delta quantity is equal to 0, it will represent a pair of straight lines. So if at all, if delta is not equal to 0 and we have h equal to 0 and a equal to b, then that will be a circle. Okay, next, if delta is not equal to 0 and we have h square equals to ab, so this will be representing a parabola. Similarly, if h square is greater than AB and not equal to 0, we have a hyperbola, and if it is less than AB, then we have an ellipse. Okay, so these figures are conic section because this can be obtained if we cut a cone with a plane. I shall discuss that in the upcoming videos. So let's move on to a question related to the general equation. So here we have a question: if x square minus 3xy plus lambda y square plus 3x minus 5y plus 2 equals to 0. Now where lambda is a real number, represents a pair of straight line, and if theta is the angle between them, then cosec square theta equals to what? So it's a double question is here. Okay, you can see we need to know lambda, and then only we can have cos square theta. So for lambda we can use, since it represents a pair of straight line, okay, we can compare this equation with ax square plus twice hxy plus by square plus 2gx plus 2fy plus c equals to 0. Then we can substitute that in our formula. Okay, our formula is abc plus twice fgh minus af square minus bg square minus ch equals to 0. This condition can be satisfied. Okay, so after substituting we will have this expression, and if you solve it we can get lambda equals to 2. But the story doesn't end here. Okay, we need to know cos square theta. So cos square theta, this can be known if we know the angle between the lines. Okay, if we know the angle between the lines, then we can use this formula. So now let's see how we can calculate the angle, then we'll come back to this problem. So here you see that we are going to calculate the angle between the pair of straight lines, which is represented either by ax square plus twice hxy plus by square equal to 0, or ax square plus twice hxy plus by square plus 2gx plus 2fy plus c equals to 0. Okay, So this, if we do not have the x and y and the constant term, then this particular equation is known as homogeneous equation. Okay, and it always represents a pair of a straight line that passes through origin. Okay, it will always represent a straight line, pair of a straight line that will pass through the origin. So if one will be y equal to m on x, the other will be y equal to m to x, which will be inclined at an angle theta. So we need to calculate this theta. So this theta can be calculated by a very simple formula. We have studied this in your 10th standards, right? So tan theta equals to plus or minus 2 under root h square minus ab by a plus b. So we'll see two typical cases here. If the lines are perpendicular, then we have a plus b equals to 0. And if the lines are parallel, to each other, then we have h square equals to ab. This is also very important. Okay. So if the lines are parallel or if the lines are coincident, means if two line lies on, like, let's say L1 is here and L2 is here, then also we'll have this condition. Now let's move back to the initial problem. Okay, we have calculated lambda. Now since we have calculated lambda, now we can go and substitute that lambda in here. So we have x square minus 3xy plus 2y square. Okay, we need only these coefficients in order to calculate the angle theta. Now let's calculate angle theta. So here you see we have tan theta equals to plus or minus 2 under root h square minus ab by a plus b. If you'll substitute the h value ab, then we'll be getting tan theta equals to 1 by 2. But since we need cos square theta, we have to change this theta, tan theta into cot square theta, which will be 3 by 1, that is 3. And if you substitute that, 1 plus 3 squared will be 9 plus 1 equals to 10. So our answer will be, what will be our answer? Our answer will be the B. B will be the answer. Let's see one more question related to the angle between the two lines. We have given equation kx square plus 4xy plus 5y square equals to 0, which intersect, which are inclined at an angle pi, which means both the lines are coincident. So you can directly solve by using h square equals to ab, which means 2 squared equals to 5k, which implies k equals to 4 by 5. So simply you can take option B is the right answer. Someone can do this way as well. Okay, but this is a lengthy process. In In-Trance, you need to follow a very shortcut method in order to get your questions done in time. So thank you guys for viewing my videos, and please like, comment and subscribe to my channels for new updates, and please suggest which topic you want to know in the upcoming videos. I will be making videos on the same. So thank you very much.